Hello guys, in this video we will go over Gaussian elimination. Essential question: how do I solve a system of linear equations using the method of Gaussian elimination? The objective student will be able to determine if ordered triplets are solutions of linear equations. So we're used to working with two systems of equations and two variables x and y. But this time we're going to add one more variable z, and we're going to add one more equation to our system. So this is how the coordinate plane would look like whenever we have three variables. So instead of just being two-dimensional, this is going to be a three-dimensional plane, okay? X on this side, y on this side, and then y gives you sort of the height, okay? So now, whenever we're looking for a solution of a system of equations that has three variables, we're going to be looking for an order pair that's a triplet. So instead of just having x and y, this time we're going to have x, y, and z, okay? Now, the same way that it used to work on the other systems of equations, x, y, and z needs to satisfy all three equations, okay? So let's go ahead and take a look at an example, okay? So take a look at these two systems, okay? So if we were trying to find what x, y, and z are, okay, which one do you think would be easier to solve? Okay, just look at the setup, look at what the variables equal to, right? Which one would be easier to solve? So on this one, there's no way I can figure out what x, y, and z are. But if you take a look at the one at the bottom, all right, it tells me that z equals 3. So if we go from bottom to top, if we know that z equals 3, we can easily take the 3 and plug it into the equation at the top to find y. So just by looking at that, I would say that the second one would be easier to solve. So let's go ahead and solve for it, okay? So since z equals 3, I can just graph my 3 and then just plug it into the second equation. So I'll show you the work over here. So I'm going to go ahead and number them 1, 2, and 3. Okay, so I'm going to go ahead and take equation 2, and I'm going to plug in z equals 3. So I'm going to write y plus 2 times 3 equals 5. So y plus 6 equals 5. Therefore, if we subtract, y equals -1. So now I know what z is, I know what y is. So I'm going to continue up top. So then that means that here I'm going to plug in 3. And here I'm going to plug in -1. Okay? So let's go ahead and do that. So I'm going to go ahead and take equation number 3. And I'm going to plug in the z that I have and the y that I have. So then I have x minus 2 times -1, and then we add 2 times 3, and that should equal 9. So let's go ahead and do the math. X plus 2 plus 6 equals 9, so we get x plus 8 equals 9. Therefore, x equals, if we subtract 8 on both sides, it's 1. So we know what x is, we know what z is, and we know what y is. So now we're ready to write our final answer. Now it is an ordered triplet. X goes first, then y, then z. So 1, -1, and 3, and that's my solution of this ordered triplet. Now, if you notice, this form right here makes a triangle, right? Sort of. There's nothing here at the bottom, okay? And x, y, and z have a coefficient of 1. This is called row echelon form, okay? That is whenever we have the coefficients of x, y, and z be 1, and then we have sort of like a triangular shape, okay, whenever we're solving. Okay, so this is important for Gaussian elimination. Our goal is to make something like this at the top look like this. And we're going to be using elimination to do that. So get ready for the next example. we're going to apply Gaussian elimination. Now, I am going to begin with just a system that has two different variables, two different equations, just so that we get used to this new method. So the goal for Gaussian elimination is to make that triangle that we saw in the other example, okay? And we get that triangle by applying elimination, okay, and by combining the equations. So the first thing that I'm going to do is I'm going to label my equations 1 and 2, okay? And remember that we want a triangle. That means that our goal is to get rid of this x right here, okay? And we're going to do that by eliminating. So if I want to eliminate the x at the bottom, we can do that by multiplying the second equation by -3. And actually, guys, let me take that back. Because remember how we want a triangle here? Besides wanting the triangle, we want this number to be 1. Now, if you look at the second equation, the x already has a 1, an understood 1 at the front. So before I start getting rid of stuff, I'm just going to go ahead and switch them, okay? So I'm going to write equation 2 at the top, and then I'm going to write equation number 1. Now we're going to go ahead and try to eliminate this 3x at the bottom. Okay, and it's basically the same thing we were going to do earlier. We're going to take equation 2, multiply it by -3, and then I'll go ahead and combine these two equations. So I'm going to go ahead and do my scratch work on the side. So once we distribute, we get -3x plus 3y equals to 0. Now I'm going to go ahead and get equation number 1 and write it underneath. And now, just like we did with elimination, we're going to combine. So that cancels out. We're going to add them. 3y plus -2y becomes just y equals 0 plus -1, -1. Okay, so now, since my goal was to eliminate this 3x, okay, now I came up with a new equation by combining 1 and 2, okay? So now instead of writing the second one, I'm going to rewrite my system, but this time, okay, the 1 at the top will stay the same. I'm just going to bring it down. And instead of writing 3x minus 2y equals -1, we're going to write what we found over here. Y equals -1, okay? Now, if you notice, the coefficients of x and y are 1 this time, and we made our triangle because there's nothing underneath x and y anymore. So that means that we are done, okay? Once we get to this point, we're going to take the -1 and we're going to go up. We're going to plug it into our equation, okay? So then I'm going to go ahead and graph x minus y equals 0. And now I'm going to go ahead and plug in the -1 into my equation. So let's go ahead and do this. X minus -1 equals 0. So that becomes x plus 1 equals 0. So we get x equals -1. So now we know what x equals, and we know what x equals. So my solution is -1, -1. Okay, let's go on to the next example. Okay, so I'm going to go ahead and begin by labeling them. And remember, my goal is to have a triangle with nothing over here at the bottom, and also to have coefficients of 1. Okay, so on this one, we don't have an x that has a coefficient of 1. So we are going to have to begin by trying to combine the equations and eliminate. Okay, so I am going to begin by trying to eliminate this -3x down here. Okay, so I'm going to go ahead and write equations 1 and 2 here on the side. Now, to eliminate x, we know that we got to multiply both equations. I'm going to multiply the second one by 8, and then I'm going to multiply the first one by 3. Since this one has a negative already, there's no need to multiply by a negative number. So let's distribute. So after we distribute, this is what we get, okay? So after we distribute, now we combine the equations, we add them up together, so this cancels out, and now we get 11y equals negative 88. So now the last thing we have to do, just, to make it as simple as possible, okay, we're just going to divide by 11. So y equals negative 8. Okay, so remember, now we are taking, so this is my new equation, okay? We're taking that equation and we're writing it instead of the second one, okay? So the first one is going to remain the same. 8x plus y equals negative 16. But equation number 2 now becomes y equals negative 8, okay, after I did the combination, okay? So now, my coefficient of y is 1, but this one isn't. So how can I make this 8 become 1? Well, by multiplying by the reciprocal. So that's my next step, and I'm going to write it here. I'm going to go ahead and take the reciprocal of 8 and multiply that by equation number 1, okay? Alright, so I'm going to go ahead and go on, and I'll do the scratch work here. So then, again, we're going to take 1 over 8, and we're going to multiply it by 8x plus y equals negative 16. Now, we are multiplying by an equation, so we got to multiply everything. So let me go ahead and write it here. Okay, my new equation is going to be when we distribute 1/8 times 8x, it's just going to become 1x. And then y times 1 over 8 would be 1y over 8 equals negative 16 over 8, which is just negative 2. Okay? So then that right there will replace the equation that goes here. So then now I'm going to go ahead and bring down my y equals negative 8. And this right here is the system, and this is equation 2. Okay, so I have a 1 here, I have a 1 here, and I have my triangle. That means that I'm done. Now I can go ahead and just plug in. I know what y is, but I'm going to plug it into the equation at the top. Okay, so let's grab this negative 8 and plug it into the y. So x plus negative 8 divided by 8 equals negative 2. So that becomes x minus 1 equals negative 2. We add 1 on both sides, and we get x equals negative 1. Okay, so I found my x, I found my y. So my solution is negative 1, negative 8. Okay, all right, so here comes the you try problems. So it's only 2. Make sure that you try using Gaussian elimination. Don't forget that you want your triangle and you want the coefficients to be 1 for x and y. And then your summary. How is Gaussian elimination and regular elimination similar? How are they different? All right, good luck.